Students, in this video, I will go through the conversion from rational exponents to an expression in radical form. Let's take a look. So up until this point, up until this lesson, we've covered a lot of different laws related to exponential expressions, in particular the product rule, quotient rule, and the power rule, and all those rules are necessary for manipulating expressions involving exponents. We haven't really talked about evaluating exponential expressions yet, although we are familiar with it. We're familiar with evaluating exponential expressions, in particular values that are integers. We now know how to evaluate negative exponents as well as positive integer values. What about fractional exponents? So this is going to be the focus of the lesson. How do we evaluate fractional exponents? So take this for example. I have 4 to the 1/2. What exactly is this? Well, 4 to the 1/2 is actually equal to 2. Now, how do I know that? Well, that's because 4 to the 1/2, if I take this and I square both sides, now that we understand the power rule for exponents, look what happens to the left-hand side. 4 to the 1/2 squared becomes 4 to the first, and the right-hand side becomes 2 to the second. So if you want to think about this, right, 4 to the 1/2 is actually the same thing as, in radical form, the square root of 2. Square root of 4. And that in return is equal to 2. Keep that in mind as we go through the different slides here. Well, what about this? What about 8 to the 1/3? How do we evaluate an expression of this kind, where again we're dealing with a fractional exponent? Well, like any instance when we do not know how to solve something, we always call that unknown something, right? Let's call it x. So just like before, okay, I'm trying to figure out what x is. So let's say if I take this and I raise both sides by the third power, the left-hand side will then become 8 to the first equal to x to the third. And what is this translating to, right? Let's try to interpret what this is saying. This is saying, well, what number, when multiplied by itself 3 times, gets us 8? That's what this is saying. That's what this is asking us to do. What is that number? If I take what number, when multiplied by itself 3 times, gets us 8? That's what this all translates to. So what's an alternative way of writing this? X is equal to 8 to the 1/3, yes, but 8 to the 1/3 is also equivalent to the cube root of 8. So this is our first connection between rational exponents and radical form. Let's try to apply this newly discovered idea, okay, with another example. So suppose, we forgot to evaluate this. What number is that? Okay, when multiplied by itself 3 times gets us 8. That number, of course, is 2. Let's try to apply this to another situation. So if I have 16 to the 1/4, that would be equivalent to the 4th root of 16. And what exactly is that? That is the same thing as, well, 16 can be re-expressed as 2 to the 4th. That's exactly 2, right? Because 2 times 2 times 2 times 2 gets us 16. Alternatively, okay, another way for us to get 16 to the 1/4 is equal to 2, we could have actually re-expressed 16 to the 1/4 to become 2 to the 4th, right? So 16 becoming 2 to the 4th, and then raise to the 1/4, and we end up with 2. So this is an alternative way of figuring that out, or of expressing it. So what does this all translate to? If what I am trying to figure out right now, okay, or let's say if I have a number a, okay, and I'm raising it by 1/n of a power, what does that translate to? That becomes the nth root of a. Okay, so this is the direct link between rational exponents and radical form. If I'm taking a number and raising it by 1/8, that is equivalent to taking the nth root of a. Let's take it a step further. Let's say if we didn't have a nice fraction, and when I say nice fraction, I mean, let's say we're not just taking raising a number to the power of 1 over n. Let's say if we take it to the power of m over n. How do we interpret that? Like, for instance, how do we interpret 8 to the 2/3? What would that be equivalent to? Like, how do we even figure that out? Or let's say 16 to the 3/4. Let's not do 3/4. Let's say maybe 5/4. Right? How do we manage to determine such expressions? Well, a way for us to figure this out is, let's try to break this down, right? A to the m over n. Let's try to apply the power rule, but in reverse. So a to the m over n can be re-expressed as a to the 1 over n raised to the m, right? Because if I were to apply the power rule, put that in there, I'll be left with m over n as the power. Alternatively, we can also re-express this as a to the m raised to the 1/n. And what does this translate to in radical form? Remember, this is the nth root of a, so which means we're going to take the nth root of a and raise it to the m power here. And consequently, this guy over here means we're going to take a to the m and then raise it to the nth root. All of these things are equivalent, by the way, right? All of these things on the right, these things here on the right, all of these is equivalent to a to the power of m over n. So these are the rules that we are going to be using in the next video, where I go over examples of exercises where we practice applying these concepts.